Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. Traditional ground station infrastructure model versus ground station as a service model. For several years, traditional ground and space infrastructure, which work together to operate and utilize space assets, were majorly built, owned, operated, and managed by government space agencies such as NASA, ESA, Roscosmos, CNSA, and a host of others in order to communicate with their spacecraft and collect data. The advent of the NewSpace has shifted the goalpost from initial government-centric ground infrastructure construction to the commercial-centric ground infrastructure construction and sophistication. For decades before the as-a-service concept came into being, established ground segment providers such as Kongsberg Satellite Services offered shared access to their antenna networks. In comparison to the traditional ground station model, ground station as a service model inspired by cloud computing offers cost effectiveness, flexibility, and ease of use, and it allows operators to focus on their core mission rather than the complex and capital-intensive task of building and maintaining their own ground infrastructure. Evolution of ground station as a service between 2010s and the present moment can be attributed to the influence of cloud computing, infrastructure as a service, new commercial entrants, growing ecosystem of providers, and entry of the major tech companies. Ground station as a service model demonstrated the benefits of shared, virtualized infrastructure and paved the way for pay-per-use model for satellite communications. The focus points are as follows: traditional ground station infrastructure model, ground station as a service model, differences between traditional and ground station as a service models, and future perspectives on ground station as a service model. Traditional ground station infrastructure model. The traditional model requires satellite operators to own, build, and maintain their own expensive, geographically limited ground station infrastructure, leading to high upfront costs and operational burdens. A traditional ground station infrastructure model consists of a ground station terminal with a large antenna and transmitter receiver, a mission operations center to command satellite and monitor its performance, and a ground station data storage and network to connect the components and store retrieved data. Malagny Station in Argentina, which is used by European Space Agency, is illustrated in this picture. The key components of traditional ground station infrastructure are ground station terminal, which is the physical site on Earth, featuring large parabolic antennas that receive and transmit signals to and from the satellite. Mission Operations Center, located at a dedicated facility. The Mission Operations Center is responsible for sending commands to the spacecraft, monitoring its health and status, and managing its overall mission. Select ground segment facilities worldwide is illustrated in this picture. Science Operations Center is an additional center for retrieving science data, processing it, and generating scientific data products for users. Data storage and network. This component provides live connectivity between ground station and mission control and temporarily stores the data received from the satellite before it's processed by the Science Operations Center and Monitoring Center. A 28.5 meter parabolic satellite communication antenna is illustrated in this picture. Ground station as a service model is a significant shift in satellite communications, democratizing access to space for new commercial players and driving innovation by abstracting ground segment connectivity. Ground station as a service model allows operators to use shared global networks of ground stations on a pay-per-use basis, similar to cloud computing. Ground station as a service offers greater flexibility, lower upfront cost, and easier scaling, enabling satellite operators to focus on their mission rather than infrastructure management. Integrated ground system is illustrated in this picture. Examples of ground station as a service model are Azure orbital ground stations, Microsoft's fully managed cloud-based ground station as a service, offering provides access to ground station infrastructure for processing and storing data received from space. Cloud provider and partner ecosystems offer platforms where partners provide ground station services, integrating with the cloud ecosystem in order to offer features such as software modems for data processing. Mesa's ground segment is illustrated in this picture. Challenges of ground station as a service model are cybersecurity risks. As ground stations become more accessible and integrated into shared cloud environments, they present a larger and more attractive target for cyber attacks. Resilience. Dependence on shared infrastructure can decrease resilience to weather variations, as operators lose the ability to route around a single ground station. Control center at NASA's Jet Propulsion Lab is illustrated in this picture. Differences between traditional and ground station as a service models. Ownership and management. For the traditional ground station infrastructure model, operators own and manage their entire ground station network, including antennas, software, and facilities. High cost. It involves significant capital expenditure for building, maintaining, and operating ground stations. Geographic limitation. Operations are tied to the locations of the operators on ground stations, potentially leading to higher latency and increased costs for global coverage. Satellite ground station is illustrated in this picture. Scalability challenges. Rapid scaling of communications to meet growth is difficult and expensive. Operational burden. Operators must handle all maintenance, security, and infrastructure and software updates. Expertise requires a high level of technical expertise in order to design, build, operate, and maintain the ground segment. Scalability. Scaling operations requires building additional infrastructure, which is time-consuming and expensive. Australia's fleet of Internet of Things ground station is illustrated in this picture. Ground station as a service model has the following characteristics. Shared global network. Utilizes a global shared network of ground stations provided by a service provider. Reduced cost. Employs a pay-as-you-go model, eliminating the need for large upfront capital investments in infrastructure. Increased flexibility and scalability. Operators can rent resources on demand and easily scale their communication capability as needed, enabling rapid growth. A simplified spacecraft system containing a space segment, ground segment, and issue segment is illustrated in this picture. Focus on core mission. With ground station as a service model, operators can focus on their satellite mission and data rather than complex ground infrastructure management. Enhanced capabilities. Access to advanced software, global coverage, enhanced security, and streamlined integration with other cloud services is provided. Improved reliability. A distributed network of stations can improve resilience against weather and other atmospheric conditions. Radio disease at an Embratel Earth station in Brazil is illustrated in this picture. Differences between traditional and ground station as a service models are as follows. Infrastructure. Traditional model owned by operator and ground station as a service model shared network. Cost structure. High capital expenditure for the traditional model and pay-as-you-go or operational expense for the GSaaS model. Scalability. Limited and expensive to scale by traditional model. Highly flexible and on-demand for the ground station as a service model. Location. Operator-owned sites for traditional model, whereby for the ground station as a service model, global provider-managed locations. Operational burden, it is high for the operator in the case of traditional model, while for ground station as a service model, it is low and handled by the provider. Future perspective of ground station as a service model are as follows. Global infrastructure. The future of the ground station as a service model will see it evolve from a specialized niche solution to a critical and integrated part of the global digital infrastructure. Satellite mega constellation, fueled by the rise of satellite mega constellation and increasing demand for real-time data, ground station as a service providers will expand beyond offering simple ground station access to become sophisticated, data-driven service platforms. Fastest ground segment as a service is illustrated in this picture. Data monetization and value-added services. Ground station as a service providers will generate significant revenue through cloud-based data analytics, AI-powered processing, and real-time data distribution. Rather than simply offloading raw data, they will offer instant, AI-driven insights to clients in industries such as agriculture, system management, and defense. Expansion into new markets. Ground station as a service will break down traditional barriers in order to enter for smaller businesses. A 28.5 meter parabolic satellite communication antenna is illustrated in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Traditional Ground Station Infrastructure Model versus Ground Station as a Service Model, presented by Dr. Ayenshola Ogundele, with the focus points: Traditional Ground Station Infrastructure Model, Ground Station as a Service Model, differences between traditional and ground station as a service model, and future perspective of ground station as a service model. Thank you.